In this lesson part, we're going to do just a smidge of lesson 16, just 16.1, to think more about compounding interest. And then we're going to turn to lesson 17 and do a couple parts there. So please be ready with us with your workbook and a calculator as well. Now, lesson 16 is all about compounding interest. So we're going to talk about the different times that we might be compounding interest, how often it happens. It changes the amount that we end up getting. So let's say that we owe 12% interest each year on a $500 loan. That $500 is telling me the amount that we started with, the starting amount of the loan. So if we borrow $500 and we pay 12% interest on top of that, that means that we are paying 100% of what we borrowed plus 12% interest on top of that amount that we borrowed, giving us a total of 112% every year. This is annual each year. And our multiplier then turns that percentage into a multiplier factor of 1.12. So we keep on practicing turning that percentage into a decimal. It wants to know what will be the loan balance after 5 years if we make no payments and we don't take out any additional money. So our expression to help us represent that is exactly what we have done before every time that we're writing an equation. We're going to have our starting amount, our multiplier factor, and we're going to raise it up to an exponent, and this is always time. Okay, so that exponent is always a time element. So we started a loan with $500. We're using our multiplier of 1.12. There's our 12% interest on top of what we originally borrowed. And if I want to find it in 5 years, I'm going to use 5 as my exponent. And then we're going to find our answer in dollars. Let's turn on our calculator. And let's type it in and figure it out. $500 times 1.12. Raise it up to the 5th power because it's been, we've had that loan for 5 years and apparently haven't made a single payment on it. We are going to owe $881.17. Now, this is why credit cards are not always so great to use, right? Because they're constantly charging you interest every single month, not even just every year. All right, with that nice reminder about compounding interest, when something compounds, it means it's like levels up and it stacks up on top of itself. All right, so if you have a compounding problem, it means you start off with a little problem, but that problem gets a little bit bigger and a little bit bigger and a little bit more. And these things, what they do is they make something even worse. To compound something means that it ends up building on top of itself. So what we're going to start seeing in lesson 16 and 17 is compounding interest. What happens is you borrow a little bit of money, and then the credit card says, sure, you can have that money as long as you agree to pay us back this much money. And then maybe you make a payment and it covers this much. So you don't owe that anymore, which is nice. That's why we make payments on loans, to try to eventually pay it off. But the next month, the credit card company comes back and says, well, you still owe us this much, and now we're going to charge you interest on all of that. So the interest that they're charging here also includes the interest that they added to begin with. So this is what I mean about kind of piling on one on top of the next and making it worse and worse. Let's say the next month you pay off a little bit more, and this time it does this. Well, yes, you don't have to pay that part back now because you've made a payment towards that loan, but there is still some loan left. And now all of this interest, and they're going to add another round of interest on top of that. So you can see how quickly someone could get into massive credit card debt. or loan debt if they only make the minimum payments. In fact, credit cards are kind of designed to do that to people. So that's why you should be very careful, right? And we'll talk more about that, I'm sure. All right. So it matters as we compound interest how frequently we do it. Interval just means how much time. It's a time span. And you may remember in our warm up, we started talking about things like annual and semi annual and biannual, monthly, weekly, or daily. So in lesson 17, we're going to start looking at what happens when they don't wait until the end of the year, but they start compounding interest every month. Let's look at 17.2. A credit card company lists a nominal APR, that's an annual percentage rate of 24%. Okay, so this is what they say. Nominal means in name. So this is what they advertise. Okay, so you may listen to credit card commercials and you may hear them say, it's got a 24% APR. And they're going to say this in an ad. So they're going to put a big starburst around it. But they don't wait till the end of the year to get their money. They want to get their money all year round. So they send you a bill every month to pay some of it, which means they compound their interest every month. Okay, so what they do is they take that 24% per year and they divide that 24% into 12 months of the year. And that's where they're going to get this 2% per month. Now, this is extra tricky that the credit cards do. Suppose a cardholder made $1,000 worth of purchases using his credit card and he made no payments or other purchases. Assume the credit card company does not charge any additional fees other than interest. Write an expression for the balance on the card after 1 month, 2 months, 6 months, and a year. So, starts off with $1,000. If we're growing at 2% per month, remember that's 100% plus 2% on top of that, 102%. And as a decimal, we're going to use 1.02. In 1 month, we're just going to raise it up to that 1 because it's that first month. Okay, so we're making sure that we're using the monthly rate here and calculating it every month. 1,000 times 1.02, $1,020. 2 months, 1,000, 1.02 to the second power. $1,040.40. 6 months. 1,000 times 1.02 raised up to the sixth power, $1,126.16. And last but not least, 1 whole entire year, 1.02, 12 months in a year. Okay, keep it in 12 because we're talking about how many months we're working with here. 1,000 times 1.02 to the 12th power. And we could do that same kind of thing for any M months without a payment. $1,000, 1.02, raising it up to any number of months. Okay. Now, question 3 is where we get the tricky part, where they're really starting to get us here. How much does the cardholder owe after 1 year without payments? We have already calculated that. They owe $1,268.24, which means the effective APR on this credit card. So effective is like in real life, okay? Reality. Up here, they took that 24 that they said, oh, it's an annual percentage rate of 24, but it compounds monthly, 2% per month. Basic math, right? They divided it up. But here, this is a little different. We're saying if we took one whole year at a time, the original 1,000 times some kind of multiplier factor, a year later, we're saying that they owe $1,268.24. If we do it all in one chunk instead of using this equation and doing it for 12 months, this multiplier is going to be different. Let's see just how different it is. If I have 1,000 times something to get to 1268, I need to divide by 1,000 so I can get that unknown something by itself. Dear calculator, what is 1,268.24 divided by 1,000? 1.268. Wait a second. 1.268. This is the effective APR. Remember to turn this back into a percentage. We're going to move that decimal point 2 places. This is 126.8%. The original 100 that we charged, it's telling me that the effective APR is really 26.8%. That's what they're adding on top of the 100% of whatever it is that we spent. In our case, $1,000. So their ad says 24% APR, but in reality, they got even more money. They actually got 26.8%. Now, they don't put this in the ad because it's more than 24. So people think, I only have to pay 2% per month, when really they end up paying more when you take it in a whole year at a time. So an expression for the balance on the card, T years without a payment. We can use this as our multiplier because that's really what it is if we look at it per year. So there's a couple ways we could write this. Still starting with our $1,000 payment. This 1.02 interest rate that they charge. And they do that every month, okay? But if we want to put it in terms of years, we do 12 months in a year. And then we could raise that up to T number of years. So I'm going to write it like this first. So we're taking our 1 year's worth of months, and then we're going to raise it up to however many years we want to do. So we could write that also like this, 1.02 times 12 times t, all of that up in an exponent. Okay. So in this case, we could find however many years. So 2 years, we could put in 2 for t and calculate it for 2 years. And that makes sense because 2 years times 12 months would give us 24 months. And this is our monthly interest rate. So credit cards are really, really tricky about how they word things and how they calculate how much money you owe them because they're trying to get the most money that they can. So lesson 17.3 asks you a really great question. It says, which one would you choose? Suppose you have $500 to invest and can choose between two investment options. This means we want the best percent rate. We want the best return. We want the best rate for us. And if we're earning interest, in this case, it means we want the highest number. Okay, remember, if we're paying out, we want the lowest number because we want to pay the lowest amount of number. If we're getting the money in, we want the highest number because we want more money, right? It's the American way. So suppose we have 500 to invest. Our first option, every 3 months, we can get 3% interest applied to the balance. Or option 2, we can get every 4 months, 4% interest is applied to the balance. Now this one is more frequent, but a lower amount. More times per year, but a lower percent. This is fewer times, but a higher percent. Okay, so we have to do some calculations to figure out which ones we should use. Okay, so let's take our option 1. Option 1, we have $500 that we are investing. It is gaining 3% interest. Okay, 1.03 is my multiplier. That's the 100% plus 3% interest on top of it. And it's going to do that every 3 months. This 3 months means that it's going to happen 4 times a year, okay, quarterly. So every 3 months is 4 times a year. So when I say more times per year, it's going to happen 4 times in a year. Just writing some notes up here so I remember when I come back and do this, I'll be like, huh, interesting. So it does that 4 times a year. And it doesn't tell me how long I put it in for. Okay, so let's just assume I do it for 1 whole year. Okay. So $500, 3% interest, compounded 4 times per year, gives me $562.75. Option 2, the same $500. This one is at a 4% interest rate. So there's my 100% plus 4 that's on top of that. And if it does it every 4 months, this means it's only doing it 3 times per year. So this time I'm going to raise it up to the 3rd power. Okay, so if you need to put that, this idea is like 3 times per year. This is the 4% interest. Three times a year, I'm going to have $562.43. Now, the difference in 1 year is not that big, but option 1 is better. And the longer I leave it in for, the better it's going to get. So it's going to keep on growing at a faster and faster rate, starting at the same amount. It's going to grow faster and faster and faster until look at how far apart these two are going to get. It's going to make a big difference down the road. So we should say option 1. The payout is better after even 1 year of time. And it will continually be better and better and better. All right, we don't have any additional practice problems from lessons 16 and 17. So if you have any extra time, use it to do any of our catch-up problems. We will have an end of unit practice problem quiz coming up shortly. So make sure you're all caught up. You can find a list of those assigned problems on our Google Classroom. Thanks.